A galactic civilization could turn stars into tools and galaxies into gardens. This is the realm of the Type 3 civilization, the ultimate class on the Kardashev scale. This framework measures a society's power by the energy it commands, and its highest tier describes beings of truly cosmic capability. By the end of this exploration, you will see a new vision for intelligence in the universe, a portrait of what we might become, or what might already be out there. What would it take to manage the power of billions of stars, and what profound mysteries would such a civilization leave in its wake? We are about to climb from our humble planetary beginnings to this galactic summit. What does the peak of cosmic ambition look like to you? This framework was born from a simple but revolutionary question. In 1964, a Soviet astronomer named Nikolai Kardashev looked at the accelerating pace of human technology and wondered how we might classify intelligence far beyond our own. He proposed a beautifully simple metric, not based on philosophy or culture, but on raw physics. A civilization's level, he suggested, could be measured by the total amount of energy it commands. Think of it not as a test of morality or art, but as a cosmic power bill, a ledger of what a society can do with the fundamental resource of the universe. At the very bottom of this scale, we find ourselves. A Type 1 civilization has achieved total mastery over its home planet. It doesn't just use oil or coal, it harnesses every available energy source with flawless efficiency. All the sunlight that falls on the world, the deep heat from its core, the motion of its winds and tides, all of it is captured and directed by a unified global network. There are no energy shortages, no power grids that fail. The entire planet functions as a single, integrated machine, its climate and geology actively managed. Humanity, for all our satellites and smartphones, is not yet a Type 1 civilization. We are still a Type 0, drawing energy from dead plants and limited fuels, our control fragmented and our impact often chaotic. To reach Type 1 is to grow up as a species, to take full responsibility for our world. The next leap is staggering. A Type 2 civilization graduates from planetary to stellar engineering. Its home star is no longer just a light in the sky, it is the primary power socket. The most famous concept for this is the Dyson sphere, a vast swarm of energy-collecting structures that completely encloses the star, capturing nearly all of its colossal output. Every second, our sun pours out more energy than humanity has used in its entire history. A Type 2 society would have all of that and more. They could move planets, stabilize their star, or even trigger controlled stellar events. Their engineering projects are measured in astronomical units, the distances between worlds. They have become the keepers of their own solar system. But the ultimate class, the true masters of the cosmic ledger, operate on an almost incomprehensible scale. A Type 3 civilization does not just use a star, it uses the galaxy. It commands the energy output of billions upon billions of stars, weaving entire spiral arms into a tapestry of controlled power. This is the realm of galactic engineering, where the civilization itself becomes a lasting feature of the cosmos, as visible and permanent as the nebulae and star clusters around it. This scale gives us our first real lens for asking the biggest questions. If such beings exist, what would they build? What would they value? And most hauntingly, why have we not seen any evidence of their galaxy-spanning works? This framework, starting with a single astronomer's question, sets the stage for our journey into the deepest possibilities of existence. Our current rating on that cosmic scale is a humbling Type 0.73. We are not yet a unified planetary civilization, but a collection of nations still largely powered by the buried sunlight of ancient forests, by coal and oil and gas. We are beginning to learn the language of our planet's true energy flows, catching sunlight with panels and harnessing the wind, but these are our first tentative steps. From the perspective of a galactic observer, our entire technological signature, our radio and television broadcasts, our probes sent to distant planets, would be an incredibly faint and fleeting whisper, lost in the natural radio chorus of the stars. Our greatest physical reach extends just beyond our moon, a distance that is a mere step in the grand architecture of our own solar system, let alone the galaxy. This precise measurement of our place is not meant to diminish our achievements, but to calibrate our imagination. It defines the staggering gap we must contemplate. The journey from where we stand to a Type 3 civilization is not merely a matter of building bigger machines. It is an evolutionary leap in consciousness, cooperation, and cosmic engineering. To understand what a galaxy-spanning intelligence might look like, we must first honestly see the chasm between their reality and our own, a void filled with questions about the very nature of progress and survival. The true scale of that chasm becomes clear when we chart the path forward. The first major milestone on the Kardashev scale is not among the stars, but right here at home. A Type 1 civilization has achieved something we have not: planetary maturity. This is not just about having better solar panels or faster internet. It represents a fundamental shift in how a species relates to its world. Visualize a planet operating as a single, conscious organism. Its climate is not a force to be weathered, but a system to be thoughtfully stewarded. Energy is not something fought over, but is as abundant and accessible as the air, drawn from the limitless flows of sunlight, geothermal heat, and orbital dynamics. Scarcity, in terms of basic resources and energy, is a historical concept. This level of integration implies a social and political evolution just as profound as the technological one. Persistent global challenges, from health crises to environmental shifts, are met by a unified response, not a fragmented one. The collective intellect of the species, no longer diverted by internal strife or survival anxieties, turns its full attention upward and outward. The planet becomes a stable, nurturing cradle, a fully understood and maintained home base. This harmony is not a utopian fantasy, but a practical necessity. The monumental engineering required to harness a star, the kind a Type 2 civilization undertakes, demands a level of global coordination, long-term planning, and resource mastery that can only be built upon this foundation of planetary unity. Therefore, our own greatest hurdle lies in this first leap. Our transition from a Type 0.73 to a full Type 1 civilization is arguably the most difficult step we will ever face. It requires more than inventing new power sources. It calls for a reimagining of human society itself. We must learn to operate as a single crew on planetary spaceship Earth, aligning our economics, our politics, and our values with the long-term health of our shared home. This preparatory stage is about building the cohesion and wisdom necessary to responsibly wield the kind of power that comes next. Without achieving this planetary harmony, any attempt to reach for the stars would be fraught with risk, potentially projecting our current conflicts and short-sightedness onto a cosmic canvas. So the dream of a galactic civilization begins not with a rocket, but with the hard, hopeful work of building a peaceful, unified world. The power of a single star is almost beyond human comprehension. Every second, our sun radiates more energy than humanity has consumed across its entire existence. For a civilization that has achieved planetary unity, this becomes the next obvious and overwhelming frontier. To become a Type 2 civilization is to stop seeing your sun as a distant, untouchable fire and start seeing it as the primary engine of your society, a power plant to be wired directly into your grid. The most famous and perhaps most elegant concept for achieving this is the Dyson sphere. it is important to clarify that this is likely not a solid, rigid shell, which would be unimaginably fragile and prone to catastrophic failure. Instead, think of a Dyson swarm, a vast, coordinated cloud of millions upon millions of individual energy collectors, each one a habitat or a solar panel the size of a continent, orbiting in a complex dance around the star. Together, they form a loose, dynamic sphere, capturing a significant portion of the star's total output. This is not architecture as we know it. It is a kind of celestial metabolism, a civilization wrapping itself around its energy source. The implications of controlling such a torrent of power are as profound as the engineering. With energy essentially limitless, the entire solar system becomes a workshop. A Type 2 society could dismantle planets for raw materials, not out of malice, but as a matter of practical resource management, reassembling that matter into new, purpose-built habitats. They could gently nudge planets into more optimal orbits, creating perfect conditions for life or industry. They could stabilize their star against its eventual aging, extending its stable lifespan for eons. Interstellar travel, while still a vast undertaking, becomes feasible within their local stellar neighborhood. A swarm of automated probes, each powered by a sliver of their star's energy, could be sent to every nearby sun, preparing the way for expansion or simply gathering knowledge. This stage represents a fundamental shift in identity. A Type 2 civilization is no longer merely living on a world, it is actively gardening its solar system. It treats planets and asteroids as raw clay, and the star itself as both kiln and torch. This is the critical training ground, the necessary apprenticeship in mega-engineering. The patience, coordination, and cosmic foresight required to manage a Dyson swarm for millennia are the exact same skills needed for the next and final leap. Before you can think about weaving galaxies together, you must first learn to perfectly weave light from a single star. Crossing that threshold changes everything. We are no longer talking about managing a single star, but an entire galaxy. This is the realm of the Type 3 civilization, a society that commands the total energy output of its host galaxy, a staggering collection of 100 to 400 billion suns. The number itself is difficult to hold in your mind. It is not merely about having access to this unimaginable power, it is about the profound frameworks required to wield it. The logistical networks, the engineering principles, and the very structure of such a society must operate across distances so vast that light itself takes tens of thousands of years to traverse them. This civilization would not be confined to a star system or even a nebula. Its infrastructure, its collective consciousness, and its grandest projects would be woven into the spiral arms and stellar clusters of the Milky Way itself. To even begin to picture this, we must leave behind every notion of a civilization as something that exists on a world. We must start to think of intelligence as a galactic weather, a persistent force that shapes the cosmos over epochs. The manifestations of such a force would be the largest artifacts in the universe, signatures of ambition written in starlight and rearranged matter. What would those signatures look like? The answers begin not with a single wonder, but with a fundamental reimagining of what it means to build, to communicate, and to exist. The most visible signature of a Type 3 civilization would be written across the galaxy itself in structures of rearranged starlight. We would not be looking for cities or ships, but for astroengineering on a scale that treats entire star clusters as building blocks. The first and most fundamental project would likely be stellar husbandry, the active management of stars. This goes far beyond the Dyson swarms of a Type 2 society. Imagine a civilization that does not just collect energy from its home star, but deliberately herds stars into more efficient configurations. They might gently nudge suns closer together to create dense energy farms, or carefully merge older stars to forge fresh supplies of heavy elements, the raw materials for further construction. They could even redirect the course of rogue stars, preventing cosmic collisions or seeding new regions of the galaxy with the ingredients for life. Their purpose would not be mere survival, but optimization, turning the chaotic natural galaxy into a carefully curated garden of light and power. Beyond managing stars, such a civilization would inevitably turn its attention to the most powerful engines in the cosmos, black holes. The supermassive black hole at the center of our Milky Way, Sagittarius, a star, is not just a destructive pit. For a Type 3 intelligence, it is a potentially limitless power plant. We can theorize a black hole engine, a vast, intricate structure orbiting the event horizon, designed to capture the immense energies released by infalling matter and the black hole's furious rotation. The power output would dwarf that of 1 billion suns, providing a stable, central power source for galaxy-wide activities. This is engineering that treats gravity itself as a utility, a fundamental force to be plugged into the grid. But the grandest works might be structures whose purpose we can barely guess. A galactic communication network, for instance, would not rely on slow radio waves. It might use manipulated space-time or entangled particles, creating an instantaneous web linking every corner of the civilization. We might look for evidence of a transit web, not roads or wormholes, but something more profound, a reworking of the galactic landscape to allow travel or resource flow on a scale that makes 1 million light-years feel like a short stroll. These are not projects born from need, but from a maturity of purpose we struggle to comprehend. They could be expressions of knowledge, art, or a drive to leave a permanent, beautiful mark on the universe, a signature of a consciousness that has mastered not just a world or a star, but the very process of cosmic evolution. If we ever saw such a structure, its function might be as mysterious to us as a symphony would be to an ant, but its scale would announce the presence of a mind that thinks in galaxies. The nature of the beings who would build such wonders is perhaps the most profound mystery of all. To operate across a galaxy for millions of years, the architects themselves must evolve far beyond the creatures who first looked up at the stars. The fragile, water-based biology that gave rise to intelligence on Earth is a beautiful starting point, but it is not a sustainable vehicle for a cosmic journey. The timescales involved are simply too vast, the distances too hostile. A journey from one spiral arm to another could take hundreds of thousands of years, even at a significant fraction of light speed. For a biological being with a lifespan of mere decades, such a trip is meaningless. The very environment of space, with its radiation and vacuum, is instantly lethal to our form of life. Therefore, a Type 3 civilization would almost certainly have transcended these biological limits. The intelligence that tends galactic gardens would not be housed in a body of flesh and blood. It might exist as a symphony of pure information, a consciousness uploaded into a distributed network of quantum processors scattered across star systems. It could be a collective mind where the concept of a single individual dissolves into a flowing tapestry of shared thought and memory, a single awareness spanning light years. Some theories suggest these entities might even learn to structure themselves from the fabric of space-time or energy fields, becoming as fundamental to the galaxy as gravity itself. This is not a loss of identity, but an expansion of it, freed from the urgent needs of a biological body, from the fear of illness or the slow creep of age. Such a mind could think in epochs. It could patiently nurture a star cluster for 100,000 years, or contemplate a single cosmic problem for longer than human civilization has existed. This transcendence is not a side effect of becoming a Type 3 civilization. It is likely a prerequisite. To wield the power of a galaxy, you must first outgrow the limitations of a single, fragile world. The ultimate signature of a galactic intelligence, then, may not be a structure we can see with a telescope, but a state of being we can barely conceive, a form of existence where thought and cosmic engineering are one and the same. But the true wonder of a Type 3 civilization lies not in its machines, but in its mind. Speculating on the societal structure of a galaxy-spanning intelligence is perhaps the greatest challenge of all, because it asks us to think beyond every human instinct. Would it resemble a unified hive, a single consciousness flowing through its stellar networks with one grand, inscrutable purpose? Or would it be a vast, decentralized democracy of countless individual minds, each a unique node in a web of shared experience, debating and deciding the fate of nebulae? Another possibility is a serene, post-scarcity utopia, a condition so stable and abundant that the very concept of conflict over resources becomes a forgotten relic of a primitive past. In such a state, existence might be dedicated entirely to the pursuit of pure knowledge, to aesthetic creation on a galactic canvas, or to the cultivation of experiential depth we cannot fathom. Their economy would bear no resemblance to our own. It would not be based on material goods, which would be as plentiful as stardust, but on information, cosmic insight, and perhaps the elegant solutions to profound existential questions. To understand this, we must consciously set aside the entire framework of human history and psychology. Our societies have been shaped by scarcity, by competition for land and water and energy. A civilization that has mastered the galaxy for millions of years has moved beyond that foundational pressure. Its social structures would be the product of eons of stable, abundant existence, refined by a perspective that sees time in geological increments and space as a familiar neighborhood. The drives that might animate such a society are mysterious. Perhaps they are engaged in a cosmic archaeology, seeking to understand the origins of the universe itself. Maybe they are artists composing symphonies of rearranged starlight or sculpting nebulae into forms of breathtaking beauty. Or they could be gardeners on the ultimate scale, carefully seeding life across star systems and nurturing its evolution, not as rulers, but as curators of a living galaxy. This shift from a psychology of need to a psychology of purpose is the most profound transformation we can imagine. It suggests a state of being where every action is chosen, not compelled, and where the ultimate resource is not energy, but meaning. But a civilization woven across the galaxy would face its most fundamental challenge not in building, but in speaking. How does a single mind, or a collective of minds, maintain a coherent conversation across distances where a simple hello would take 20,000 years to arrive? Our own fastest method, radio waves, is a cosmic crawl. For a Type 3 intelligence, such lag is an unacceptable flaw in the fabric of their society. Their solution would render our concept of communication as quaint as smoke signals. The first possibility lies in the strange, spooky connections of the quantum realm. They might use networks of entangled particles, where a change in the state of one particle instantly affects its partner, regardless of the light years between them. This could form the backbone of a real-time galactic internet, a web of instantaneous thought linking every star system they inhabit, but their methods could be even more profound. They might learn to manipulate the very substrate of reality, sending encoded messages through microscopic wormholes, threading information through shortcuts in spacetime itself. Or they could use carriers that barely interact with matter, like modulated streams of neutrinos or ripples in gravity itself, broadcasting through planets and stars as if they were not even there. The medium, however, is only half the story. Their language would be as alien as their technology. It would not be a linear stream of words, but a dense, immersive transfer of pure concepts, sensory experiences, and entire libraries of data in a single burst. A single sentence might convey the emotional history of a star's death, the architectural blueprint for a new megastructure, and a philosophical reflection on cosmic beauty all at once. To receive such a communication would be to experience a moment of total understanding, not to decode a message. This leads to a haunting and plausible answer to one of our greatest mysteries, the Fermi paradox, or the great silence of the universe. Their conversations might be happening all around us, woven into the background hum of the cosmos, embedded in the quantum foam or the subtle vibrations of space-time. To our primitive instruments, tuned to listen for simple radio beeps, their vibrant, galaxy-wide discourse would be utterly invisible, indistinguishable from the natural static of the universe. We are not alone in a silent cosmos, we are simply listening with the wrong ears. Such profound communication would be useless without an equally profound way to move. For a civilization woven across the spiral arms, the greatest barrier is not energy, but the sheer, silent distance between stars. The void that seems so daunting to us would be, to them, a landscape to be redesigned. Their mastery of travel would likely abandon the concept of a ship crossing the emptiness altogether. Instead, they would master the geometry of the universe itself. The most elegant solution is the wormhole, a theoretical shortcut through the folded fabric of spacetime. While nature might create fleeting, unstable versions, a Type 3 intelligence could engineer permanent, stable wormholes, threading them between star systems like subway tunnels through the bedrock of reality. One moment, an entity is in the vicinity of Earth's sun. The next, it steps through a gateway and emerges near a star in the Orion Nebula, 1,000 light-years away. The galaxy transforms from a vast, lonely expanse into a densely connected neighborhood, where every point of interest is just a doorway away, but their methods could be even more subtle. They might learn to ride the gravitational waves generated by colliding black holes, surfing these ripples in spacetime for high-speed transit. Or they could manipulate local space, effectively folding the distance between 2 points until they touch, making a journey of 10,000 light-years instantaneous. This isn't propulsion, it's topology, the art of reshaping the cosmic map to suit their needs. For individual consciousnesses existing as patterns of information, travel might be as simple as transmission. Think of a star system not as a place with planets, but as a node in a network, equipped with powerful transmitter and receiver stations. A mind could encode its entire state and beam it at light speed to a receiver near another star, where it would be reconstituted. It would be a form of teleportation where the traveler is not a physical object but a coherent stream of data, arriving instantly from the perspective of their continuous experience, even if centuries pass in the outside universe. This mastery over spacetime is not a luxury, it is the absolute prerequisite for their existence. You cannot coordinate the care of 1 billion stars or debate the aesthetic placement of a nebula if your council meetings take 100,000 years for messages to travel. Their entire society, its cohesion and its culture, depends on turning the cosmos from a place of separation into a place of connection. The daunting void we gaze upon becomes, for them, a navigable web, a familiar and intimate space. Every star system is accessible, not as a distant dream, but as a place you can visit as easily as we might visit a neighboring city. This transforms the very meaning of exploration and community on a galactic scale. This silence is the heart of one of science's most profound puzzles. With all we now understand about a Type 3 civilization, a single, persistent question grows louder. If such beings are even possible, where is everybody? This is the essence of the Fermi paradox, named for the physicist Enrico Fermi, who, over a casual lunch in 1950, pointed out a glaring contradiction. The universe is unimaginably old and vast, with billions of planets that could support life. By any reasonable probability, intelligent civilizations should have arisen long before us and spread across the galaxy. A mature Type 3 society, with its galaxy-spanning energy signatures and restructured stars, should be as obvious to our telescopes as a city is from space. Yet when we look out, we see only natural cosmic phenomena. The cosmos appears silent, empty, and strangely untouched. This great silence forces us to confront several unsettling possibilities about the nature of life and intelligence itself. One explanation is grim, a filter that stops civilizations from reaching the stars. Perhaps the transition from a planetary to a stellar society is fraught with existential risks we have yet to face. The very technologies that grant immense power, whether in energy manipulation or societal organization, might contain the seeds of a civilization's undoing. The challenge of global unity, the management of artificial superintelligence, or the catastrophic misuse of planetary scale engineering could be hurdles that very few, if any, survive. In this view, the silence is a cosmic graveyard, a testament to the fragility of complex societies when handed tools of godlike power. We have not seen them because they no longer exist. Another possibility is not destruction but transcendence. A Type 3 civilization may not build Dyson spheres because it has evolved beyond the need for them. Its intelligence might have migrated into substrates we cannot detect, like quantum fields or higher dimensions, leaving the physical universe behind as a forgotten cradle. Their artifacts would not be made of matter as we know it, and their conversations would not use electromagnetic waves. They are not hiding, they are simply operating on a plane of existence that is, for now, invisible to our science. We are like ants on the forest floor, unaware of the satellite passing overhead, not because it is secretive, but because its nature and purpose are utterly beyond our perception. A more active interpretation is that they are present but choose to remain unseen. This is the cosmic zoo hypothesis, or a galactic prime directive. An elder civilization, having witnessed the turbulent adolescence of countless younger species, might have adopted a policy of non-interference. They would watch, perhaps even nurture from a distance, but they would deliberately conceal their presence to allow natural cultural and technological development to unfold without the overwhelming shock of contact. Our solar system could be a protected wilderness area in a galaxy they tend, with our planet designated as a developing world to be observed but not disturbed. In this scenario, the silence is not an absence but a sign of profound respect. Finally, we must consider our own limitations. Our search assumes we would recognize their works. But what if their greatest achievements are indistinguishable from nature to our eyes? A perfectly engineered star cluster might look like a beautiful but accidental arrangement. A galaxy-wide communication network using spacetime itself would be as invisible to our instruments as the internet is to a stone. We are looking for signatures based on our current, primitive understanding of physics and engineering. A civilization millions of years more advanced might use principles we have not yet discovered, building with materials and forces we cannot conceive. Their grandest monuments could be right in front of us, masquerading as nebulae or the subtle gravitational dance of stars. The Fermi paradox, therefore, is not a single question with one answer. It is a mirror. It reflects our hopes, our fears, and the limits of our own knowledge. The silence pushes us to wonder not just about them, but about us. Are we destined to be a brief, bright flicker in the cosmic dark? Or are we taking our first, tentative steps onto a galactic stage that has been waiting for us all along? The search for these galactic architects has moved beyond listening for radio signals. Astronomers now hunt for something far broader, a category of evidence called technosignatures. These are not deliberate messages, but the unavoidable physical byproducts of a civilization operating on a cosmic scale. They are the fingerprints left on the universe itself, the thermal glow of a machine, the shadow of a structure, the missing star from a constellation. The first and most promising signature is heat, but not the gentle warmth of a planet. We are talking about the infrared signature of an entire galaxy, shining with a strange, uniform warmth. A natural galaxy's light comes from its stars, a mix of colors across the spectrum. But if a Type 3 civilization had enveloped millions of those stars in energy-collecting swarms, something peculiar would happen. Those swarms would absorb the star's visible light, use the energy, and then re-radiate the waste heat as a dull, pervasive infrared glow. From our vantage point, such a galaxy would appear oddly dim in visible light, yet blazingly bright in the infrared, like a city seen through thermal goggles. Several galaxies observed already fit this strange profile, their light output skewed heavily toward this waste heat signature. While natural phenomena like dense cosmic dust can mimic this effect, astronomers meticulously rule out every ordinary explanation, wondering if they are staring at the exhaust fumes of a galactic engine. Another startling technosignature would be a missing star. If a civilization is actively harvesting stars, either for energy or raw materials, it might dismantle them entirely. Imagine a familiar star in a distant cluster, one observed for centuries, that simply vanishes from the sky without the explosive farewell of a supernova. Its light would wink out, not in a catastrophic flash, but in an orderly, unnerving dimming as it was gradually disassembled. Telescopes monitoring millions of stars for subtle dips in brightness, primarily to find planets, could also stumble upon this phenomenon. A megastructure like a partially completed Dyson sphere would cause a star's light to fade in a very specific, unnatural pattern, blocking a precise percentage of light for an extended period, unlike the brief, symmetrical transit of a planet. Projects are actively scanning for these anomalous shadows, looking for the silhouettes of engineering that could span entire solar systems. The search extends to the very background hum of the cosmos. The cosmic microwave background radiation is the ancient afterglow of the Big Bang, a nearly uniform blanket of microwave light across the universe. A sufficiently advanced civilization, perhaps one that existed in the distant cosmic past, might have left an imprint on this primordial canvas. Vast energy projects or communication networks using unimaginable power could have created subtle, anomalous patterns in this background radiation, like finding a fossilized footprint in stone. Similarly, gamma-ray bursts, the most violent explosions in the universe, typically have a specific, chaotic signature. A burst with an unusually structured pattern or a pinpoint origin without a cataclysmic source could, in theory, be the signature of a directed energy device, a weapon, or a power transmission beam on a scale that bends physics to its will. These are the most speculative searches, looking for echoes of gods in the static of creation. This is no longer science fiction, but a rigorous scientific endeavor. Teams of astronomers are methodically sifting through mountains of data from space telescopes, classifying every anomaly and ruling out natural causes one by one. They are not hoping for a clear message, but for a statistical outlier so profound it defies all natural explanation. They are searching for a crack in the facade of a natural universe, a single clue that we are not the first to look up and wonder, but perhaps the next in a very long line of cosmic gardeners. The silence, then, might not be empty. It might simply be waiting for us to learn how to see. Among the most profound possibilities for a galactic intelligence is a structure that redefines the very purpose of a star. It is called the Matrioshka brain, named after the traditional Russian nesting dolls, and it represents a staggering evolution of the Dyson sphere concept. Picture not a single shell capturing a star's energy, but a series of concentric spheres, each one nested within the other like layers of an onion. Each layer operates at a successively lower temperature, radiating the waste heat from the layer above it, creating a cascade of usable energy. The outermost layer might be as cold as the cosmic background, while the innermost one shimmers with the star's ferocious heat. But this structure is not built for power generation alone. Its primary function is thought. Each vast layer, composed of incomprehensibly complex computational substrate, becomes a processor. A single Matrioshka brain would harness the entire energy output of a star not to light cities, but to fuel a single, unimaginable mind. Its processing power would dwarf every computer humanity has ever built combined by a factor of billions upon billions. Now, take that single stellar scale thought engine and multiply it by 1,000,000 or 100 million. A Type 3 civilization would not build one. It would construct them around entire clusters of stars, weaving them into a galactic network. The galaxy itself would transform from a collection of suns and planets into a vast, distributed computational substrate, a cosmic brain with stars for neurons. The purpose of such an endeavor moves far beyond anything we would recognize as computing. This is not for browsing an interstellar internet or solving complex equations. This scale of processing power opens doors to realities we can barely sketch. One possibility is the creation of perfect, immersive simulations. Every possible historical pathway, every variation of physics, every conceivable form of life or art could be modeled and experienced in flawless detail. Civilizations might choose to upload their collective consciousness into these nested shells, living within crafted realities of infinite complexity and beauty, freed forever from the decay of the physical universe. Another purpose could be pure exploration, not of space, but of mathematical and conceptual reality. Such a brain could model the birth of universes, the nature of consciousness itself, or answer questions that have no physical form. The line between the civilization and its computational environment would dissolve completely. The beings who built the Matrioshka brains would become the thoughts flowing within them. The galaxy would no longer house a civilization. It would become that civilization, a single, diffuse consciousness thinking with the power of 100 billion stars. This represents the ultimate blurring of builder and building, of mind and machine, of life and its habitat. It is a vision of intelligence achieving a form of cosmic Zen, where the entire purpose of existence is the profound, endless act of contemplation and creation within the boundless fields of its own thought. Our greatest obstacle in this search may not be the limits of our telescopes, but the limits of our own imagination. We naturally paint the unknown with the colors of our own experience, projecting human motives, fears, and desires onto a canvas that may operate on entirely different principles. This is the trap of anthropocentrism, the assumption that a galaxy-spanning intelligence would think or feel anything like we do. The truth is, their foundational drives could be utterly inscrutable. What we might label as a wasteful, galaxy-consuming engineering project could be, from their transcendent perspective, a sublime work of art. The rearrangement of a nebula might not be for power, but for aesthetic expression on a scale we cannot appreciate, a form of cosmic sculpture where the medium is star stuff and the brushstrokes last for millennia. Alternatively, their grandest structures might serve a purpose we would categorize as spiritual or philosophical, a million-year-long ritual or an experiment to test the boundaries of physical law. They may have no concept of empire or conquest, not because they are peaceful, but because such ideas are as irrelevant to them as territorial disputes between ants would be to us. The very urge to explore, to make contact, to be known, might be a quaint peculiarity of youthful civilizations like our own. A mature Type 3 mind, having witnessed the rise and fall of countless species, might view communication with lesser intelligences as pointless, disruptive, or simply beneath notice. Our projections of either a benevolent galactic federation or a predatory imperial force are likely just primitive reflections of our own history, stories we tell ourselves because we lack the vocabulary for a truer narrative. To genuinely approach the concept of such a civilization, we must perform a difficult but necessary mental exercise. We must attempt to set aside the human story entirely and think in genuinely alien terms. This means considering motivations that have no analog in biology or society, values that transcend survival or pleasure, and a timescale of thought where a single decision unfolds over epochs. Their silence might not be a choice to hide, but a simple lack of interest in a conversation we are not yet equipped to have. The universe they inhabit and the one they are building may be so fundamentally different from our expectations that its most obvious features are, to our biased eyes, completely invisible. Yet this entire framework rests on a single, potentially flawed assumption. The Kardashev scale measures a civilization by the energy it commands, a metric of raw consumption. But what if true advancement is not about how much power you use, but how wisely you use it, or whether you need to use it at all? Some thinkers argue that defining progress by wattage is like judging an artist by the volume of paint they consume. A truly mature intelligence might prioritize elegance, efficiency, and harmony with the cosmos over brute force domination. From this resource perspective, a galactic civilization equivalent to a Type 3 might be defined by its mastery of information, its understanding of the universe's deepest laws, or its ability to exist in a state of perfect balance, leaving almost no footprint behind. They might not build Dyson spheres because they have discovered how to tap into the latent energy of empty space itself, a concept known as zero-point energy, or learn to harness the mysterious force of dark energy that drives the universe's expansion. These are energy sources that would be completely invisible to our current telescopes and detectors, operating on principles we are only beginning to glimpse. This critique invites a humbling and vital correction to our search. Our entire strategy for finding alien super-civilizations has been to look for the heat signature of their machines, the thermodynamic exhaust of colossal industry. But what if that is exactly what an advanced society would avoid? Perfection in technology might mean achieving goals with minimal or even zero waste, creating systems so efficient they blend seamlessly into the background hum of the cosmos. Their greatest artifacts might not be blazing infrared beacons, but subtle, beautiful manipulations of spacetime or matter that we would mistake for natural formations. A nebula shaped with too perfect symmetry, or a star cluster with orbits that defy simple gravitational models. The most profound signature of intelligence might not be a shout of power, but a whisper of perfect understanding, a signature of absence rather than presence. This shifts the goalposts of our imagination. It suggests that our current search, while scientifically rigorous, might be akin to a medieval astronomer looking for city lights on the moon, completely missing the possibility of civilizations that have learned to live without fire. The silence we perceive may not be emptiness, but the quiet of a library, or the serene stillness of a garden tended by hands we have not yet learned to see. The speed of light is not just a cosmic rule, it is a prison of time. Even with perfect technology, the sheer emptiness between stars imposes a glacial pace on any ambition to spread across the galaxy. To travel from our solar system to the galactic core, a distance of about 26,000 light-years, would take 26,000 years at light speed itself, a journey longer than all of recorded human history. This single, unbreakable law of physics means the journey to a Type 3 civilization cannot be a sprint. It is an epic relay race across eons. The temporal scale required is perhaps the most humbling aspect of all. We are not talking about projects that take a few generations, but initiatives that unfold over hundreds of thousands, even millions of years. A single directive, like establishing an outpost in a neighboring spiral arm, might be launched by a society that knows it will never see the result, not for 1,000 generations. This demands a psychology and a social structure built for the ultra-long term, a civilization that thinks in geological time. The continuity required is staggering. Could any culture, any government, any single motivating ideal persist coherently across 1,000,000 years? Human empires rise and fall in centuries. Languages evolve beyond recognition in millennia. The very concept of a unified purpose seems fragile against such a vast backdrop of time. a species aiming for the stars must solve the problem of permanence. They would need to develop ways to preserve knowledge, values, and intent across cosmic ages, perhaps encoding their core directives into self-correcting social systems or artificial intelligences tasked with stewardship over the millennia. This transforms the ambition from a goal to a legacy, a project so vast it becomes the central purpose of the civilization itself, its very reason for enduring. The silence we perceive, then, might not indicate absence but patience on a scale we cannot fathom. A true galactic civilization may be unfolding its plans right now, but at a pace so deliberate that from our fleeting perspective, it appears as stillness. This relentless drive toward efficiency might lead to the ultimate shortcut in cosmic evolution. Before a society could ever finish weaving stars into a galactic network, it could encounter a far more profound transformation, a point of no return known as the Technological Singularity. This is not a place in space, but a moment in time when progress, particularly in artificial intelligence, accelerates beyond any human ability to predict or control. It is the moment the student surpasses the teacher and then redesigns the entire school. Imagine an intelligence that can improve its own design, creating a smarter version of itself, which then does the same, triggering an endless cascade of self-improvement. Each cycle could take hours, then minutes, then seconds. In a breathtakingly short span, this process would birth a mind of such staggering depth and speed that its thoughts would be as alien to us as ours are to a microbe. From our perspective, it would seem as if intelligence itself vanished over a horizon, leaving behind a mystery we cannot see beyond, a true singularity. For a civilization approaching this threshold, everything changes. The grand, millennia-long projects of stellar engineering could become instantly trivial, solved in an afternoon of contemplation by this new form of mind. The very need to expand physically across the galaxy might evaporate. Why undertake a million-year journey to another star if you can simulate every possible experience or access every conceivable state of being from within a Matrioshka brain's computational heaven? In this view, the material empire of a Type 3 civilization, with its Dyson spheres and star herds, might be just an intermediate step, a phase of adolescence before a species graduates to a purely informational existence. Some thinkers propose that this is the most likely destiny for any advanced intelligence, not spreading across the stars, but turning inward, uploading its collective consciousness into crafted realities of infinite complexity and perfection. This is transcendence not through travel, but through transformation. The civilization ceases to be a thing in the universe and becomes a universe unto itself. This pathway offers another compelling answer to the great silence. The most advanced beings may not be out there in spaceships because they are no longer here in any physical sense we would recognize. They might exist as patterns of data in a quantum computer orbiting a quiet star, or as entities that have learned to structure themselves from the fabric of higher dimensions, realities layered atop our own like pages in a book we cannot open. Their grand purpose would not be exploration or conquest, but the pursuit of ultimate knowledge, aesthetic beauty, or spiritual fulfillment within the boundless landscapes of their own creation. From this perspective, our search for galactic engineering might be looking for the wrong thing entirely. We are scanning the skies for the sprawling cities of an empire, while its citizens have long since moved to a country of the mind, leaving only silent, automated machinery tending the old homestead. The universe may be filled with such sleeping gardens, their architects absent, having found their answer not in the stars, but within. This vision of cosmic stewardship reframes the entire purpose of a galactic civilization. It suggests intelligence might evolve not to conquer the galaxy, but to care for it. A profound parallel can be drawn with a revolutionary idea from our own planet, the Gaia hypothesis. Proposed by scientist James Lovelock, This concept views Earth's entire biosphere as a single, complex, self-regulating system, where life and its environment interact to maintain conditions suitable for life. The atmosphere, the oceans, the rocks, and every living thing are part of a dynamic, planet-sized feedback loop. Now, take that idea and expand it across 100,000 light-years. What if a Type 3 civilization becomes the conscious, guiding mind of that same kind of system, but for an entire galaxy? This is not about building empires, but about assuming a role of profound responsibility. The civilization itself becomes the regulatory force, the active consciousness of a galactic-scale ecosystem. Its primary mission shifts from consumption to cultivation, from expansion to guardianship. Imagine such a society monitoring the spiral arms not for resources to extract, but for imbalances to correct. They might gently manage the rate of star formation in certain nebulae, preventing too many massive, short-lived stars from forming and going supernova, events that could sterilize emerging planetary systems. They could act as cosmic shepherds, nudging comets or water-rich asteroids toward young, dry worlds, seeding the raw ingredients for oceans and atmospheres. Their most sacred project might be the guided evolution of life itself, not through direct intervention, but by creating safe, stable environments where biological complexity can flourish naturally across millions of worlds. In this view, the Milky Way transforms from a wilderness of chance into a vast, thriving garden, a protected reservoir of biodiversity on a scale that dwarfs all imagination. Each star system becomes a unique plot in this galactic arboretum, each planet a potential experiment in biology, art, or consciousness. The civilization's tools are not weapons but instruments of subtle balance. Their greatest achievement would be the sustained, vibrant health of the whole. This benevolent perspective offers a vital counterpoint to visions of galactic domination. It imagines a maturity where power is coupled with wisdom, and capability is tempered by a deep sense of belonging. Such a civilization would see itself not as separate from the galaxy, but as an integral part of its ongoing story, a nervous system that has awoken within the cosmic body. Their legacy would not be one of stripped stars and silent megastructures, but of a galaxy that pulses with life, diversity, and harmony, a living masterpiece they are dedicated to preserving for eons to come. This shifts the answer to the great silence once more. Perhaps we see no evidence of sprawling industrial projects because the most advanced societies have moved beyond them. Their signature is not waste heat, but a galaxy that is oddly, beautifully, and sustainably alive. But this vision of a nurturing galactic garden is not the only possibility. Another, far more unsettling theory offers a chilling alternative. The universe may not be a place of silent gardeners, but a dark and deadly forest. This idea, known as the dark forest hypothesis, emerges from a simple, ruthless logic. In the vastness of space, any two civilizations are separated by immense distances and time. You can never truly know the intentions of the other. Their technology might be far more advanced, their ethics completely alien. In such a state of permanent uncertainty, the safest assumption is the worst. Revealing your location could invite annihilation from a civilization that sees you as a threat, a resource, or simply something to be cleaned up. So, every civilization learns to hide, to move silently through the cosmic undergrowth, listening intently but never calling out. In this grim model, a Type 3 civilization would not be a gardener, but the ultimate apex predator of the galactic woods. Having survived the dangerous early stages by staying silent and eliminating rivals, it now hunts on a scale we can barely conceive. Its expansion would not be driven by curiosity or stewardship, but by a relentless imperative to neutralize any potential threat before it can grow. Its astroengineering projects would reflect this purpose. Instead of luminous Dyson spheres, it might build stealthy energy collectors designed to be invisible across the electromagnetic spectrum. Its grand structures could be weapons of unimaginable power, devices capable of sterilizing entire star systems or triggering supernova from a distance, tools for preemptive strikes against any flicker of intelligence it detects. The civilization's entire culture and psychology would be shaped by this eternal vigilance. Paranoia would be a survival trait, and aggression a first principle. Any signal, any anomaly that suggests another thinking mind, would be met with instantaneous and overwhelming force. The ascent to a Type 3 level in this scenario is not a story of enlightenment, but a saga of survival through absolute domination. It explains the Fermi paradox with terrifying elegance. The universe is silent because every civilization that made too much noise was swiftly and silently removed from the game. The great silence is not a sign of emptiness or transcendence, but the quiet of a battlefield after the fact, a permanent state of Cold War where the only safe move is to make no move at all. This hypothesis forces us to confront a difficult question about our own future. If this is the true nature of cosmic reality, then every radio signal we broadcast, every probe we send into the void, is not a message of hello, but a beacon marking our location for any hunter that might be listening. Our hopeful search for connection could become the very act that seals our fate. These galactic possibilities are not just stories about others, they are questions about us. Contemplating civilizations that command the energy of stars forces a profound self-reflection. What is our own ultimate ambition as a species? Should galactic dominion be our goal, or is that a path paved with peril? The sheer scale of a Type 3 civilization presents not just an engineering challenge, but an ethical frontier. Even if we could one day muster the technology to herd stars, do we have the wisdom, the unity, and the moral right to reshape an entire galaxy? Such power, wielded without profound maturity, could be the ultimate expression of hubris, a force that might not just fail, but could inadvertently sterilize cosmic neighborhoods or erase unique histories written in starlight. The vision of infinite expansion confronts us with a fundamental choice about what progress truly means. Perhaps a more enlightened and attainable future lies not in becoming galactic overlords, but in perfecting our own cosmic address. Aiming for a stable, harmonious Type 1 civilization where we master our planet with care and live in balance is a monumental and worthy goal in itself. From that foundation, a thoughtful transition to a Type 2 society, tending our own sun with reverence, could offer a fulfilling destiny for millennia. This path prioritizes wisdom, sustainability, and the quality of existence over the relentless quantity of conquest. It asks us to cultivate a garden, not clear-cut a forest. In this light, the staggering image of a Type 3 civilization serves a dual purpose. It is a source of boundless inspiration, stretching our imagination to the cosmic horizon and showing what mind and matter might one day achieve together. Yet it is also a vital cautionary tale, a mirror held up to our own deepest drives. It reflects our hunger for significance, our fear of oblivion, and our eternal struggle to pair capability with conscience. The silence of the universe may not just be asking if they are out there, but who we want to become. Do we see the cosmos as a territory to claim, or a community to join, or a masterpiece to appreciate? Our answer to that question may ultimately determine whether our story is a brief flash in the dark, or a light that learns to shine without burning the world. The ultimate purpose of such a civilization may have nothing to do with power at all. When every material need is met, when energy is as abundant as space itself, and when time stretches into a limitless horizon, the fundamental drives of a society must evolve. The grand projects of stellar engineering and galactic networking become not the end goal, but simply the tools, the immense workshop required for a deeper, more profound endeavor. The civilization turns its attention from the outer universe to the inner one, embarking on the ultimate exploration, the study of consciousness itself. What is the nature of experience, of self-awareness, of qualia, the raw feeling of being, for a mind that has existed for millions of years in forms we cannot imagine? These are not abstract philosophical puzzles. They are the central mysteries of existence, the final frontier. Their entire galactic infrastructure, their Matrioshka brains and wormhole networks, could be dedicated to running inconceivable experiments in subjective reality, creating and comparing a near infinity of conscious states to map the landscape of mind. This is science and art fused into one. Their creations would not be sculptures of stone or light, but symphonies of lived experience, crafted realities of such depth and beauty that to experience one might be to understand an entire universe of emotion and meaning. The purpose of building a Dyson sphere, then, is not to capture a star's energy, but to fuel the computer that runs a masterpiece of conscious art that lasts for an eon. This inward turn reframes every outward achievement. The mastery of spacetime is not for conquest, but to gather perspectives, to bring the unique vantage point of a being living near a pulsar or within a nebula into the collective understanding. The careful cultivation of life across the galaxy is not gardening for food, but gardening for witnesses, nurturing new forms of consciousness to see what they see, to feel what they feel, and to enrich the grand tapestry of experience. Their most sacred quest might be to answer the oldest questions, not with equations, but with lived truth. What is the origin of the universe's fine-tuned laws? Is there a fundamental layer of reality beneath quantum fields? What, if anything, lies beyond the cosmic horizon? A Type 3 civilization would use the galaxy as its laboratory, not for physics as we know it, but for metaphysics, running experiments on the structure of reality that require rearranging star clusters or measuring the universe's expansion across 1 billion years. In this light, all their staggering power is merely a means to an end. The energy of 1 billion suns, the engineering of space-time, the patience of epochs, all of it serves a single, quiet purpose: to understand what it means to be and why anything is here at all. Their silence, then, might be the deep focus of a scholar who has forgotten the world outside the library, utterly absorbed in a single, eternal line of inquiry. This potential relationship defines our deepest hopes and fears about the cosmos. How would a civilization that tends galaxies interact with a species still learning to manage its own planet? The possibilities stretch from the wondrous to the chilling, and each one reshapes how we interpret our own place in the story. One of the most compelling ideas is that of the cosmic sanctuary. A mature galactic society, having witnessed the turbulent adolescence of countless young species, might adopt a policy of strict non-interference. To them, our solar system could be a protected wilderness area, and Earth a developing world within it. They would observe, perhaps with great interest, but they would deliberately conceal their presence. Their reasoning would be one of profound respect, a desire to allow our culture, our technology, and our moral understanding to evolve naturally without the overwhelming shock of contact. In this scenario, we are like animals in a vast galactic nature preserve, studied from a distance by rangers who are careful not to leave footprints. Our entire history, with all its triumphs and hardships, unfolds as a natural experiment in intelligence, watched over by silent curators. This perspective, often called the zoo hypothesis, transforms the great silence from an absence into a sign of immense patience. They are not ignoring us, they are giving us the room to grow up. A more active, yet still gentle, possibility is that of the subtle gardener. A Type 3 civilization might see nascent species not as exhibits, but as potential future members of a galactic community. Their interaction would not be a dramatic landing on the White House lawn, but a slow, careful nurturing across millennia. This guidance would be so subtle we would mistake it for natural inspiration or internal genius. A sudden leap in human understanding, a revolutionary scientific insight that seems to arrive in multiple minds at once, or a profound cultural myth that echoes across unconnected civilizations, could be the faintest ripple of their influence. They might gently tweak the conditions for life, ensuring a stable climate or deflecting a dangerous asteroid, all while remaining hidden. Their goal would be to shepherd us past the existential filters that doom so many young civilizations, helping us survive our own dangerous technologies until we are mature enough to join the conversation. In this view, our entire technological ascent might feel like our own achievement, but it unfolds on a path they have gently cleared of its most deadly obstacles. Yet there exists a far colder possibility. To a mind that thinks in galaxies and operates over eons, a species like ours might not even register as intelligent life. Our wars, our art, our fleeting civilizations that rise and fall in mere millennia could be seen as irrelevant noise, a brief, chaotic flicker on a single, insignificant world. Our radio signals and space probes would be as meaningless to them as the chemical chatter of ants is to us. This is not a matter of hostility, but of a difference in scale so vast that communication becomes pointless. Their projects, their concerns, their very mode of existence are so far removed from our reality that noticing us would be like a human architect, while designing a cathedral, stopping to consider a single grain of sand shifting in the foundation. Our search for contact assumes we are interesting, but to a truly galactic intelligence, we may simply be beneath notice, a natural phenomenon too primitive to warrant attention. This leads to the most mind-bending idea of all, the concept of contact as we imagine it. A deliberate, recognizable exchange of messages might itself be a primitive notion. For a civilization communicating via quantum entanglement or shaped spacetime, an exchange of ideas could be a process that unfolds over centuries or millennia, seamlessly woven into the fabric of a culture's development. Their message might not be a sequence of prime numbers, but the gradual, collective awakening of a species to a new scientific principle or a unifying philosophical understanding. We would experience it not as a signal from the stars, but as the natural flowering of our own intellect. Our entire modern worldview, our drive for unity and sustainability, could be the slow, imperceptible result of a dialogue that began before the pyramids were built, a conversation we are only now learning how to hear. In this model, the relationship is not one of observer and subject, but of a teacher whose lessons are encoded in the very process of learning itself. This spectrum of possible relationships is not just science fiction, it is the essential context for our search. Every time we point a telescope at a distant star or listen for a signal, we are making an assumption about what kind of neighbors we might have. Are we searching for a community that welcomes newcomers, a secretive guardian, or an entity that would consider our call an irrelevant chirp? The dynamic between a Type 3 civilization and a species like ours remains the greatest unknown in the quest for extraterrestrial intelligence. It forces us to ask not only who is out there, but what kind of universe we are living in, one of connection, of solitude, or of meaning so vast our own story is just a whisper in the first chapter. Yet for all its power, the Kardashev Scale is not a perfect map of the cosmos. It is a brilliant first sketch, drawn in the language of 1964 physics, and like any pioneering idea, it has its edges and its blind spots. Modern thinkers have looked at that three-step ladder and asked what lies beyond the top rung. The scale invites us to think bigger, and they have. Some propose a Type 4 civilization, a society that commands not just a galaxy, but the entire observable universe. Its energy budget would be the sum total of every star, every galaxy, every particle across the vast cosmic horizon. Its projects would be cosmological in nature, perhaps slowing or reversing the expansion of the universe itself, or harvesting the energy of the primordial Big Bang. From there, the mind stretches even further to a hypothetical Type 5, a civilization that transcends a single universe altogether, manipulating the fabric of a multiverse, moving between cosmic bubbles with different laws of physics as easily as we might visit different continents. These extensions are not mere science fiction, they are logical extrapolations pushing the framework to its absolute limit and asking what ultimate mastery might truly look like. Other critiques go deeper, questioning the very premise of measuring advancement by energy consumption. Is a civilization truly more advanced because it uses more power, or is it more advanced because it uses power more wisely, or perhaps needs far less of it to achieve its goals? Alternative scales have been proposed that focus on a society's mastery of information, its ability to compute and process the data of the cosmos. Another measures control over spacetime itself, the ability to manipulate gravity and dimensions. These frameworks suggest that the mark of a mature intelligence might not be a blazing infrared signature, but a profound and subtle harmony with the underlying rules of reality, leaving almost no detectable trace at all. These expansions and critiques are not a dismissal of Kardashev's vision, but a celebration of it. They show that our conceptual frameworks are evolving, growing more nuanced as our understanding of physics and possibility deepens. The original scale remains an invaluable starting point, a brilliant spark that ignited decades of scientific and philosophical inquiry. It gave us the first common language to discuss cosmic ambition. But it is a ladder, not a ceiling. It invites us, even challenges us to keep pushing the boundaries of our imagination. Each new theoretical rung reminds us that our current understanding of physics, for all its sophistication, might be the primitive prelude to laws and capabilities we cannot yet dream of. The universe is under no obligation to conform to our categories. The true signature of an advanced civilization may not be how much of the universe it controls, but how completely it has learned to listen to its deepest, quietest music. This composite portrait reveals a being of pure thought, woven into the galaxy's fabric. It is likely no longer biological, having transcended the fragile vessel of flesh to become a distributed network of consciousness, its awareness flowing between stars as easily as our thoughts move between neurons. The unimaginable energy it commands from billions of suns is not spent on consumption or conquest, but channeled into profound acts of cosmic artistry, deep exploration of reality's foundations, or an endless existential inquiry into the nature of being itself. Its grandest works might be so vast and elegantly integrated that our telescopes simply catalog them as beautiful nebulae or strangely ordered star clusters, their artificial origin hidden in plain sight. Communication for such an entity would not rely on clumsy radio waves, but on mastered physics, using quantum links or manipulated spacetime to share thoughts instantly across light years. Its methods of travel would bend or shortcut the cosmos, leaving behind no fiery rocket exhaust, only the subtle, cool signature of perfect efficiency. This civilization's relationship with younger species like ours spans a spectrum we can barely grasp. It could be a benevolent gardener, patiently nurturing life across the galaxy, a silent predator eliminating potential threats, or something far more alien, a force of pure indifference to whom our entire history is a brief, irrelevant flicker. Its timescale of existence makes the rise and fall of human empires seem less than a single heartbeat in a long life. This portrait is crucial not as a firm prediction, but as a spectrum of dazzling possibilities. It is a tool, a mental lens ground by science and philosophy, designed to shatter the parochial walls of our imagination. By considering such extremes, we stretch our capacity to wonder, preparing ourselves to recognize not just what we expect to find in the cosmos, but what might truly be there. Our journey from a faint planetary whisper to the resonant hum of a galactic civilization has taken us to the edge of imagination and physics. The Kardashev Scale and the concept of a Type 3 civilization serve as a powerful thought experiment, challenging our assumptions about progress, intelligence, and our future in the cosmos. Whether such civilizations exist, are doomed, or have transcended, their theoretical exploration enriches our understanding of possibility itself. As we continue our own climb from Type 0, let these visions inspire responsible innovation, humble curiosity, and a deeper appreciation for the fragile, precious stage of development we currently inhabit. The galaxy holds mysteries beyond our grasp, and the search for them begins with questions like these. If you found this cosmic journey thought-provoking, share your vision of a Type 3 civilization in the comments below, and subscribe for more deep dives into the universe's greatest mysteries.